Hello there.
Hi guys.
My name is Eric. I am 10 years old.
I'm Eliza and I'm 12 years old.
Because of coronavirus, people have been homeschooling and doing school online.
We thought because we've been homeschooled our whole lives that we should record some of our favorite activities and lessons to give you guys some ideas.
Yep.
Today we are doing math.
We're just giving you some ideas. You can either do what we're doing or use our ideas as inspiration for something that you do.
Today's lesson is for all ages. We will be teaching the lesson for pre-K through about our age, which is about pre-algebra.
We are going to ask our sister Clara to help us with the high school kids.
We use Singapore Math and Khan Academy. Khan Academy is online, and that is what we use for our math curriculum. These are just extras to give you guys some ideas, so it's more fun for Shark Week.
Make sure to have your shark mascots with you to help you with your math.
You will need to gather some materials. You will need a pencil, a marker, a deck of cards, index cards, any size, or strips of paper if you don't have any, normal dice, and if you have some multi-sided dice.
And don't forget your shark mascots.
The first thing that we are going to talk about is greater than and less than. This is adaptable for all ages. It can be from little kids to much older kids. You will need a greater than and less than shark. Here are ours.
We found ours on almostunschoolers.blogspot.com, but you can also make your own. We will have a link up here. You will also need an equal sign shark. We just made our own. We just drew our own. We're going to start with playing cards. You can use the jokers as wild cards, and the face cards are 10, but aces are either 1 or 11, you can choose. You can adapt it to make it easier. You could take out the jokers and the face cards if you want to.
The first thing that you are going to do, the dealer is going to put down one card and then put down another card.
Then the player will pick out a shark and put it in the middle. So a queen is 10 and a jack is 10, so that means it would be equal. And you read from left to right, so it would be 10 is equal to 10. Now let's try this again. 9 and 10, because king is a 10. So it would be 9 is less than 10. And make sure that the open mouth is eating the larger number, because the shark is hungry. 9 is less than 10. Now let's try this again. 5 and 4, so that would be 5 is greater than 4, because the shark is eating the higher number. 5 is greater than 4. So that's the basics of this game. You can adapt it to whatever your level is.
You can use multiple cards, so you can put 2 here on this side and then 2 on this side. You can either multiply them or add them, so it makes it a little bit more difficult.
Another way to adapt it is you could use dice. You could put 1 die on each side, or you could do many dice on each side, or you could do multi-sided dice. You could add, subtract, divide, multiply, any way you want to make it harder or easier. You could also use index cards to make math problems, and you could use addition, subtraction, multiplication, and division, and use them like you would for playing cards.
In order to decide if it's greater than, less than, or equal to, you have to solve the math problem first.
You could also use dice to make a fraction. So the first rule would be the numerator, and the second rule would be the denominator.
Then you would have two fractions, and you would have to figure out if it's greater than, less than, or equal to. You can also use the index cards to make your own fractions.
The next thing we're doing for math are word problems. You as a parent can make word problems for your children, but so can your children. Make them based off of real life situations, based off of sharks that help for your level of math. And we have a few examples for you.
We will have the answers to the word problems at the end of the video. We will have a title screen letting you know that if you are not ready, you can pause the video before getting to the answers. The first word problem is addition. Ryan has seen 3 whales and 2 sharks. Then, on vacation, he saw a dolphin, 2 more sharks, and another whale. A. How many dolphins has he seen? B. How many sharks has he seen? And C. How many whales has he seen? The second word problem is subtraction. A great white has 10 friends. 6/10 of them are sharks. The rest are turtles. A. How many turtles are there? Write in simplest form. The third word problem is multiplication. A tiger shark is 4 feet long. A great white is 3 times the tiger shark. How long is the great white? The last word problem is division. There were 200 sharks at a party. They were split up evenly into 3 groups. A. How many were in each group? And B. How many were left?
The first word problem I will be doing is for elementary algebra. 3 hungry sharks come across a school of 200 fish. The first shark eats 5 more than the second one, and the second one eats double the amount that number 3 does. How much did each shark eat? The second word problem I will be doing is for geometry. A diver decides to go down in a shark cage to get some pictures of a nearby great white shark. The cage is a rectangular prism with a square base. The volume of the cage is 40 square feet with a height of 10. What is the side length of the base? For this word problem, you will need a calculator. This is for algebra. A population of tiger sharks consisted of 3,000 sharks in 2018. In 2020, this same population consisted of 3,200 sharks. Find the exponential growth function of the population. Round the growth rate to the nearest thousandth. Find the doubling time of the population. And find the approximate number of sharks in the year 2030.
Thank you for participating in Shark Week!
Make sure to like, subscribe, and turn on notifications
so you never miss one of our uploads!
Thank you!
Okay, so how many dolphins has he seen? So where it says on the first sentence, there are no dolphins. Ryan has seen 3 whales and 2 sharks. On vacation, he saw 1 dolphin. And just 1. So that would just be 1 dolphin. And then, how many sharks has he seen? So you see, Ryan has seen 3 whales and 2 sharks. Then on vacation, he saw 2 more sharks. So that's 2 plus 2 equals 4. Okay, now, C. How many whales has he seen? So there's 3 whales, and then another whale, another 1 whale. So that's 3 plus 1 equals 4. Okay, so 6/10 are sharks and the rest are turtles. So I will just put 10 tenths minus 6 tenths equals 4 tenths. Oof. Tenths. And then the simplest form would be 2/5. Okay, so we already know the equation here because it's 4 times 3, which is pretty easy. 4 times 3 equals, so you would, yeah, it's 12. Okay, so there were 200 sharks at a party. They were split up evenly into 3 groups. So 200 and 3. So that would be 200 divided by 3. So 66 remainder 2. So there were 66 in each group, and there were 2 left.
For this problem, we're starting with 200 fish. We'll subtract 5 because that is the number that shark number 1 eats. Now, we know that shark number 1 eats the same amount as shark number 2 plus 5. Since we've already taken out 5, we're left with 195. Shark number 2 eats double what shark number 3 eats. So we can say that as, let's label these as letters. Shark A will be the first shark. Shark B will be the second, and shark C will be the third. So we know that C plus 2C plus 2C plus 5 equals 200, because the first shark eats 5 more than the second, but the second is double the third. So since we already have 195, we will divide that by 5. So that leaves C equals 39. So that's how much shark number 3 ate. Now, to find how much shark number 2 ate, we will multiply that by 2. Shark number 2 equals 878 fish. So let's write that down. C equals 39. B equals 78. And that leaves us with A, who ate 78 plus 5, which we can add that pretty easily. 83 fish, and then we will check our work by adding all of these together to see if we get 200 again. Get 200 again. So shark C ate 39 fish, shark B ate 78 fish, and shark A ate 83 fish. This is the geometry problem. We know that the volume of the cage is 40 cubic feet. We also know that volume is the same as length times width times height. So to find the length times width, which is also known as the base area, we divide the volume by the height, which is 10. So 40 divided by 10 equals 4. Now we know that the cage is a rectangular prism with a square base. That means that the length and width must be the same. So for that, we can just take the square root of 4, which equals 2. So length is 2 and width is 2. Now just to check our work, 2 times 2 equals 4 square feet. And 4 square feet times 10 feet equals 40 cubic feet. This is our more complicated algebra problem, which you will need a calculator for, which I have right here. So for this, the easiest way to go about this is to start by setting the new population equal to the old one as a function. So before we start with that, this is the exponential growth rate function. P at time 0, population at time 0. E, which is an irrational number used in graphing exponential functions, to be kt. K is the growth rate and t is time. So, since we have our new population, let's set that equal to 32,000 equals 3,000 e to the k times 2, because there's 2 years between 2018 and 2020. So here, now we just solve 3,200 divided by 3,000, and that leaves us with e to the 2k. So to simplify that, we will take the natural log, abbreviated as ln. It's also shown as log base e of 3,200 divided by 3,000 equals 2k. And then once we get the natural log of this number, we will divide all of that by 2, which will leave us with k. So here we take the calculator, natural log of 3,200 divided by 3,000, which we will take there. And then since we need to divide it by 2, just divide the entire thing by 2. And since we're rounding to the nearest thousandth, that's 0.035 2. So that's our growth rate. Now the function is p of t, that shows that it is a function, equals, since it's a function of t, equals 3,000, since 3,000 is our population at time 0, e to the 0.032 t. Now, the doubling time of the function is pretty easy. Since we already know the growth rate, here, let me put out this relationship. K times t equals the natural log of 2. And then that can go any other way. K equals t divided by the natural log of 2, or t equals, oh wait, I did that wrong. Natural log of 2 divided by t. Capital T always stands for doubling time. Lowercase t just means the time. So growth rate equals natural log of 2 divided by the doubling time. With that, you can find the growth rate, and you can find the doubling time by finding the natural log of 2 divided by the growth rate. Since we don't know what the doubling time is, we're going to use this part. Since we do know the growth rate, we are going to do natural log of 2 divided by 0.032. And we're just going to round that to the nearest year. Since that's 21.6 roughly, that's going to be t roughly equals, that's what that symbol means, 22 years. Now, the approximate number of sharks in 2030. Since we already have the function, P of t equals 3,000 e to the 0.032 t, we just substitute t with the number of years between 2030 and p of 0, which is 2018, as we see up here. So 2030 minus 2018, that's a pretty easy subtraction. That's 12 years. So we're going to substitute that for t. So it's going to be 3,000 e to the 12 times 0.032. And that's pretty easy to calculate. We'll take the calculator again. 12 times 0.032, that's 0.384. And now we're going to raise 3,000 e to that power. So 3,000 e, don't forget the e because that will skew your calculation by a lot, to the answer. That's, so P of 12, we're going to round that to the nearest shark. So that's 4,404.4. So we're just going to round that, 4,404 sharks.